Okay, students, in this video, I'm going to walk us through how to build the Beer-Lambert plot for the data that we collected in this experiment. You have already done linear graphs before, so if you remember how to do that, please feel free to skip this video. So what I've done here is I have input all the data we collected in this part of the experiment. So here are the 5 test tubes and the absorbances that we recorded at 630 nanometers. Now, the Beer-Lambert plot is not going to plot the absorbance versus the test tube number. We need to calculate what is the molarity for each one of those 5 solutions that we made. And for that, we use the dilution formula. Over here on this cell, I have put in the rearranged form of it so we can calculate what is the final molarity. Remember, M1 is the molarity of the test solution, which is 0.200 molar. V1 is the milliliters of that solution that we put in that test tube, which actually corresponds with the test tube number. We designed it that way on purpose. And V2 is the final volume of the solution. Remember, it's not the volume of water that we added, it's the final volume of the whole solution, which is 5 milliliters for all 5 test tubes. If you want, you can do the calculations by hand and just simply input the values here in this column. But I'm going to take advantage of the formula function of Excel and have Excel calculate them for me. So I'm going to click here in this cell to start with, and to activate the formula functions, we type in the equal sign, and I'm going to put in these numbers here. So M1, remember, is 0.200 molar times V1, but in these formulas, you use the asterisk to indicate multiplication. And this will be 1 milliliter, but remember that we said that we had conveniently numbered the test tubes according to the milliliters that you're going to put of test solution in each. So what I'm going to do is I'm going to click that cell A2 where the number 1 is, and Excel's going to copy that value over here. Now I'm going to divide all that by the final volume, which we said was 5.00 milliliters, and then click enter, and voila, there it is. Now, I could retype all of that again, but what I can do here is, again, I can use a function of Excel in copying and transferring formulas. So I'm going to click that cell again that I just did. On the bottom right, there's a little dark square, and you can see that when I hover my cursor over it, it turns into like a narrow plus sign. If I click and hold that and then drag it down the rest of the column, Excel is going to copy that formula across the column, but at each one of these values, it's going to reference the value of the cell that's next to it. So for example, in this line is going to reference this cell. You can see there A3, which is this value here. This one's going to reference A4, which is 3 milliliters, and so forth. The next thing we need to do is we need to make sure that we have the proper significant figures. As we know, the actual molarity of our test solution was 0.200 molar. In other words, it had 3 decimal places. So we need to adjust all of these. So I'm going to select that column. And over here on the top, there is a set of commands that says numbers. And one of them has little arrows and decimals in there, tells you this is how you can increase decimals. So I'm going to click one time there. And as you can see, it converted everything to 3 decimal places. As I mentioned earlier, the first 2 values, when we calculated them by hand, they actually went 0.0400 and 0.0800 because we were respecting significant digits. However, because the molarities in this case only go as far as 3 decimal places, we're going to keep everything to 3 decimal places. Okay, now we are ready to do our graph. Just like before, we're going to select the 2 columns that we're interested. Remember, it's the molarity and the absorbance, not the test tube number. And then we're going to go up here to insert. We're going to scroll to the right until we find the charts. And we're going to find the one scrolling down that gives you the scatter plots. And we're going to do the scatter plot with no lines in it. And there we go. Let me bring it over here so that we can magnify it a little bit later on. Now we had to do several adjustments. First of all, we need a title for our chart. So over here on the top, I'm going to change this into a Beer-Lambert plot of Viridis solutions. Okay, now we need to label our axes appropriately. So I'm going to click on the graph, and over here there's this big plus sign that gives you chart elements, and I'm going to use it to add axis titles. And now I'm going to label these appropriately. Remember, we are plotting here the absorbance, so I'm going to put absorbance in there. Now remember that we had to indicate what was the wavelength. So this is going to be at 630 nanometers, I'm sorry. And then on the bottom, what we have is we have the concentration of the Viridis. Concentration of Viridis. And this is going to be in units of molarity. Remember that we don't typically have units for absorbance. And actually, you know what I'm going to do here is I'm going to fix this a little bit. I'm going to say not 630, but at 630 nanometers. So it is clear that 630 nanometers is not the units of absorbance. It's just the wavelength at which we're measuring it. Remember that in your case, in your experiment, you're not going to be doing Viridis. You're going to be doing a solution of cobalt to chloride. Okay, the last thing that I need is I need my equation of the line. So I'm going to go here again to my chart elements addition, and I'm going to scroll down to where it says trend line. I'm going to click that so it'll draw a trend line for me. And then I'm going to click this arrow here on the right so I can add a few things. So over here where it says more options, that's going to pull up a menu here to format the trend line. And I'm going to put here display equation on chart and display the R-squared value. And there we have it. Now what we're going to do next is, now that we have the Beer-Lambert plot, we have the equation of the line, which essentially relates the absorbance to the molarity. Now over here where we put our unknown and the absorbance of the unknown, we're going to use this data so that we can now calculate what is the molarity of our unknown. Okay, we have our Beer-Lambert plot, and what I've done here is, because it was kind of small, I've copied over here the equation of the line, y equals 4.155x plus 0.164. In this type of equation, remember y would be the absorbance, x would be the molarity. And so what we need to do now is we need to rearrange this equation, because in our case, we have the absorbance, we need to solve for the molarity. So let's rearrange. And let's say that this is actually going to be x equals y minus 0.164, all of that divided by 4.155. So that is the formula we're going to be using. Again, you can do these calculations by hand and just input the value in your data sheet. But what I'm going to do is I'm going to come over here again, and I'm going to use the formula function of Excel. Once more, I'm going to put it in this cell over here. Or if you prefer, so we can use it later on, how about if we just put it over here? We're going to say here the molarity of the unknown. We have 0.568 is the absorbance. So that's the value of y. So we're going to say y, which is this guy. I'm going to put a parenthesis there. I'm going to refer that value there. Minus 0.164. Close the parenthesis. I'm going to divide by 4.155. And I'm going to click enter. And that should give me the molarity of my solution. Now, that value there, as you can tell, has too many decimals, too many sig figs. And we know that our molarities in here are limited to a maximum precision of 3 decimal places. So yeah, what we're going to do is we're going to come back here to where it says numbers. And this time what we're going to do is we are going to actually decrease the decimals. So here we go. 1, 2, and 3. And now we have the molarity that we want. I'm going to boldface it so you can see it very clearly. So according to this, the molarity of this unknown solution is 0.097. Now, before you turn in your report, you always want to make sure, does that make sense? Notice that this absorbance, 0.568, is somewhere between the values here, 0.446, 0.606. It's somewhere in there. In other words, your molarity should have been somewhere between 0.080 and 0.120 molar. Is that correct? Yes, it is. So remember, before you blindly and in a rush turn in your results, make sure that they make sense. You know, now that you have this formula here, if you wanted to, you could have other unknowns in here. Let's say that you have another unknown number, let's say number 2, and let's say that this one had an absorbance of 0.758, for example. Well, now you have the formula up here, and you can simply select that cell, look for the square in the bottom till it becomes a thin plus sign, drag it down, and it gives you the molarity of that solution, which would be 0.143. Does that make sense? Yeah. 0.758 is somewhere between 0.120 and 0.160. So 0.143 seems like a reasonable result. Okay. Now you can go and do this with your cobalt 2 chloride solutions and the data you've been provided. Get your Beer-Lambert plot, find the equation of the line, and use it to determine what is the concentration of your unknown solution. Thank you.